In this video, I'm going to discuss pH and pOH. So right off the bat, I just want to give the definition/equations of what these are. So pH is equal to the negative log of the concentration of H+, right? Or from the last video, hydronium ion, same thing as H+. pOH is equal to the negative log of the concentration of hydroxide ion. And then pH plus pOH is equal to 14. Now, why 14? That comes from the auto-ionization of water. So water, well, basically reacts with itself to form plus OH minus. Right, so that would be the auto-ionization of water. You can set this up as an equilibrium. Right, K is equal to the concentration of H3O plus times the concentration of OH minus over the concentration of H2O. Right, but because water is a liquid, we don't include that in the equilibrium expression. And here we call this Kw because it has to do with water, and it's equal to the concentration of H3O plus times the concentration of OH minus. Now experimentally, these values have been found to be 1 times 10 to the minus 7th molar. So that's where you get, when you multiply this together, 1 times 10 to the minus 14th. You take the negative log of that, and that's 14. So the higher the number, so if the number, or pH, is greater than 7, that means you have a basic solution. Your concentration of OH minus is greater than your concentration of H plus. Now if pH is less than 7, then it's an acidic solution. And your concentration of H plus is greater than your concentration of hydroxide ion. Then of course if your pH is equal to 7 exactly, that means you have a neutral solution. Another note to make about pH, and this is an important one. A change of 1 in pH is equal to a change in 10 times acidity or basicity. Because pH is a logarithmic scale, if I change a pH by just 1, so go from say 6 to 7, I'm changing the concentration or the acidity and basicity of it 10 times, right? And I'll do a quick example to show you this. So if pH drops from 8 to 5, a solution is here 10 to the third times more acidic. It's 10 to the third because 3 pH units, and because it's a logarithmic scale, 10 to the third, so it's 1,000 times more acidic. So don't think that, just a change in half a pH unit or 1 pH unit is small. That's a big change in acidity or basicity. So I want to finish off the pH and pOH here with an example problem. So lemon juice has a pH of 2.03. Calculate the concentration of hydroxide ion. So there's a couple ways to go about it. first thing I'm going to do is calculate what the pOH is, because if I have pOH, I can then calculate OH minus concentration from there. So based on the equations from the first slide, pOH is equal to 14 minus pH. So that would be just 14 minus 2.03 to give 11.97. So now, right, pOH is equal to the negative log of the concentration of OH minus. Mathematically, how I get rid of this log is this is right, log base 10. I raise each side to the power of, the best way to say it, I raise each side to the power of 10, right? So on the log side, I end up just getting concentration. And then on the other side, I get 10 to the negative pOH, because the negative sign comes from the right side, is equal to the concentration of OH minus. So 10 to the negative 11.97 equals the concentration of OH minus, and that is 1.07 times 10 to the minus 12th molar. I also could have calculated the concentration of H plus from the pH and then used Kw to get the concentration of OH minus. That was another way I could do it. There's no right or wrong way. This was the first way I thought of, but it's just one of the ways we can calculate the concentration of the hydroxide from the pH that's given.